Hello, everybody. Welcome to the 28th of January on a nice Thursday evening, 7:30. We have a really interesting talk for you tonight. Someone that I have actually seen speak, I think, 3 times, and he's always the one person that I always explain to other people. If you ever get a chance to go and watch him because he always shows these pretty awesome live coding or something which always blows my mind. And I'm sat there as a sort of geek, but not like a full-on geek. And I'm sat there like my mind has just gone. So I'd like to introduce you to Ben Foxall tonight. And let me just bring you on. Hey, Ben, how are you?
Yeah, I'm good, thanks.
Awesome.
Thanks for those kind words.
Yeah, good stuff. So tonight you're going to speak about what exactly?
So I was going to talk about how we can use the web and web browser tech to visualize interesting data. And in particular, I was going to show a bit of a demo about visualizing lidar data from one of our sensors.
Awesome. So just to be clear, you're here tonight, but as yourself, you're not here to represent the company you work for, which is Oxbotica. And at Oxbotica, you are the front-end adventurer. That's how your description.
I have referred to myself as that.
So you're mainly web focused, but could you just give a bit more information on sort of what you do and go from there?
Yeah. So I work on the web team at Oxbotica, and so we. Oxbotica is a autonomy systems company, and the web kind of has a lot of functions in the company for kind of different bits of data, different processes that we have, and together with the rest of the web team, I help build some of the kind of tools for that. And the kind of adventurer part is we get a lot of data, and we've got a lot of interesting problems, and I feel like I get to kind of throw myself at those quite a lot.
And sort of have a play and see what you can break and fix.
Exactly.
It sounds like the ultimate job, especially for it.
It's a lot of fun. Yeah.
So what's the geekiest thing you've done around the house to start with? That's a question that's sort of.
Okay, cool. So what's the geekiest thing? I guess these lights are kind of controllable across here. I've kind of set them to the right. I don't know if that's geeky. We had a Christmas tree. That's probably it. We had a Christmas tree, and I managed to kind of hook up all the lights so that they're able to be kind of turned on in different colors and patterns and stuff like that.
So that was pretty cool. That's pretty cool.
Yeah.
That's cool stuff.
Less festive, more geeky.
So for those that are watching with us tonight, we sort of said if you can have another device with you. So ideally you want this on the big screen watching our beautiful faces, or an iPad or something, and then maybe a phone or something like that with you. And at some point tonight, we'll be broadcasting a URL for you to go to. Go to that on your phone. Ben will explain obviously more, but just ideally get another device ready with a bit of battery. So could you go through your steps? So you originally started at, was it White October, as sort of the tech lead?
Yeah.
What's that transition been like?
Yeah, so I worked at White October, which is a kind of web development agency in Oxford, and I worked there for a few years and learned a ton and helped form the kind of front end team there. And then I decided I was getting quite involved in the community, tech events and kind of sharing knowledge. So I went into kind of developer relations roles, so kind of helping people use tech. And then I did that for a little while, and then did a few kind of random little bits, and then ended up working at Oxbotica. So I actually worked there for a 4-month stint, and then I went away traveling. And the plan was, I was like, I'll go and live somewhere else and be I don't know. I don't even know where we were planning to go. But then the spanner in the works was Oxbotica was super fun. And so I was just okay, I guess we're going to come back to Oxford again. But yeah, that's where I'm at.
And you're in Dublin at the moment, from my understanding.
Yeah, we were just chatting before. It's so I've been splitting my time. My partner lives in Dublin, and I've been splitting my time between Oxford and Dublin, but then since lockdown happened, there's been no kind of office to go back to in Oxford, so I've been in Dublin getting to know it. And
that's, I guess, the beauty of code, is that it doesn't actually matter where you are.
Yeah, I mean, one of the things that's cool is we're building web tools that let you do things remotely, and suddenly that's pretty important. It's yeah.
Cool. Perfect. So throughout the evening, if anyone's got any questions, please put it into the Facebook or the YouTube chat. We can then pull it up and put it on screen or ask. And what we'll probably do is sort of a quick Q&A if there's time at the end, as opposed to stopping halfway through and trying to ask you a question. So welcome, Ben. So thank you everyone for joining, and let's start if that's cool with you.
Sure, totally.
Awesome. Right. Let me turn off. Perfect. Cool. Over to you.
Nice one. I was going to share my screen. So we were chatting before. This is quite in some ways a bit of an awkward kind of demo to give or a talk because I've got quite a few moving parts. But so you might have to bear with me, but hopefully it'll work out all right. So I am going to show you some slides. What we got here. Cool. Actually, do you know what? I'm going to just show them like this. I take it you can see this, right?
Yep, we're all good.
Cool. I like how normal the whole kind of like, can you hear me? Can you see this?
Yeah.
Has become.
You can't see any of us, can you? It's a bit of a thing, but we're here if you need us.
Cool. Good. So we did cover this just now. Thanks a lot. I'm Ben, and yeah, that's what this is. So I just wanted to say I'm really happy to be here, and especially like Will, I think I was looking back through my emails, and you emailed me in September about this, and then I was just like terrible at replying and all that stuff, and but I really appreciate you inviting me and coming along, and I think it's amazing. I think people who come to events don't always realize how much organization goes into it. And you and Josh and everyone have been really, really great with everything. So yeah, thanks a lot for that. It's really cool. So as you said before, I'm really up for answering questions. So yeah, plonk them in Facebook or YouTube. I'm also on Twitter as Benjamin Ben. So if you want to tweet me later on anything, I can try and answer stuff. One thing I would say, like, so it might be challenging for me to answer like broader questions, like should I use lidar in my car, So I can. But if you have any questions about what I'm going to show tonight, fire them my way, and I'm happy to kind of like answer them as best I can. But So I work at a company called Oxbotica. So we write software and systems for autonomous vehicles. And on that, within that company, as we just talked about, I work in the web tools team. So there's a few of us who work on kind of tooling the bits in between, which is cool. What we do at Oxbotica, we write software for vehicles to drive themselves. We've got this tagline of universal autonomy. So what that means to us is, I think best put by an example. Like, so this is a fleet of our cars that were, this is a couple of summers ago down in London in a really kind of complex city environment with like lots of pedestrians and buses and all that stuff. And this fleet, we're all driving simultaneously in autonomy around this complex environment. And then a couple of days later, that same software was running in a completely different vehicle type. So an off-road vehicle in a completely different environment. So this kind of idea of universal autonomy is like, we're writing stuff that is kind of generic enough to be adaptable to different kind of vehicles, places, and hardware as well. So, sorry, this is kind of getting to a point. So a close-up of that car, you can see some of the kind of the systems that we integrate with. This kind of pointy thing here is a radar. Which is really cool. We also got cameras out here that have like, and we often have different types of cameras on our cars to test different systems. And then these two ones here are sensors that I'm going to talk about today. And those are cool because they have lasers inside them. Like I like lasers. They're kind of fun. And the sensors, I mean, I guess, being all Tesla enthusiasts, you probably have heard about lidar and you're interested in this kind of thing. So lidar is basically laser-based imaging, detection, and ranging. So it's like being able to sense your environment by firing a laser at it, essentially. Someone pointed out last time I was talking about this that laser is also an acronym for like light amplified by simulation of emission of radiation. So, but it's like, I like how there's like, it's kind of like an acronym within an acronym, which is kind of cool. I don't know if there's like more of those. I like to put this, I think much to my colleagues' disappointment, that it's like radar, but with light. So if you imagine radar bouncing radio waves off something and receiving it back and timing that and working out positions, that's kind of what lidar is like. But don't tell anyone that I said that. So yeah, the thing the sensor I was going to talk about today is this particular sensor. So this is called a Velodyne puck, and you can see how big it is by hand there. And yeah, like nice little sensor, it's been around for quite a while now. And yeah, it's pretty cool. You can download all these kind of schematics for it if you want to bolt it onto something. And we kind of bolt on that car you saw before. We had one bolted on the top right and one bolted on the top left as well. And yeah, you can kind of do stuff with that. This is what it looks like without its kind of protective sheath on, and kind of opened out a little bit. And you can see down the side here, on one side, there's some lasers, and those fire out through this lens. Then they bounce off something, come back the other side, and then get taken into that sensor there. And then you can kind of like, and while it's doing that, it's spinning around really, really fast. And so you can kind of get this like sweeping field of view, which is kind of nice. The thing I quite like about this picture is that it looks like super cute. You know, like it's really kind of like, it's like a little face with little eyes. And yeah, I don't know, I like that. So the two things you get back from firing a laser at something, the first thing is the time of flight, like how long it takes to bounce off something and come back. And that, knowing that, you can work out the distance to that object. And then the other thing, when that laser comes back, you can detect how bright it is. And what that tells you is the kind of reflectance of the object that it just bounced off of. You know, like, so if you got a lot of the light back, it means that you've hit something maybe like metallic-y or kind of a road sign or something like that. So yeah, those are the two things that you can kind of tell from that. So communication. So if I had one of these puck things on my desk, which I don't actually at the moment, how would you kind of get information in and out of it? So it's basically just like sits on your network, right? Like, so it has an address and you can send it messages like you'd send it to another laptop on the network or a printer, and then it can send other information elsewhere. So it's kind of, there's nothing magical about it. It's just a very kind of, a device on your network, I guess on your car network in this case. And this is how you work. Like, so basically you send it a message, and that message encodes what kind of properties you want it to have while it's spinning around, and where you want it to send its data. And then once that happens, it basically just like spams whoever or whatever you wanted it to send to. And so you can do this. You can do this to kind of get lots of information out of it. And this would work, as I say, it would work on your desk just as well as it would work on the side of a car. We are going quite deep into this, and I'm not going to apologize because it's kind of interesting, but just so you know, this will be relevant. We're not just like, I'm not just showing you like intense looking diagrams for the sake of it, but this is an intense looking diagram. This is what another data sheet which tells you how to understand the data that's coming back. So basically, you've set it up on your network, it's sending messages out as fast as it can. This is what one of those messages looks like. So basically, it's got a number of bytes, and those bytes have different blocks in it. And each of those blocks has different values in it. And each of those values has a different, like, a distance and an intensity in it. And that's kind of what the data includes. So, and the way you use this, like, so you might write a program that you run, and when you run it, it sends a message to the lidar, it starts spitting messages back, and then you're able to use that data to drive your car somewhere, or kind of put your I don't know, do things. And so yeah, you tend to have a program that kind of feeds in this information, does stuff with it, and works out stuff about its environment. And this is the kind of programs that we write at Oxbotica. They're usually a bit more complicated sounding than drive car please, but you could think of it like that. What's nice about this using just standard network stuff is that you can use tools to analyze a network. And so this one here basically picks off packets and saves them to a file. And this is a PCAP file, which is like, so this is a very standard way in networking to kind of analyze data traveling through a network. And you can use this to kind of analyze it at a later date if you want. Cool. Which brings us, so now you know all the background about that kind of stuff. So that brings us to today, like just now. And what I'm going to talk about is how we can take data from that Velodyne puck that has been serialized into a PCAP file, and how can we view that in a web browser? Like what kind of process do we go through? Can we even do it? You know, like it seems like quite an odd thing to connect a web browser to a laser. But yeah, that's what we're going to do today. Before I get started, I just wanted to kind of point out, in Oxbotica, we don't drive our cars with JavaScript. Like, there's not a kind of like, you don't have to dismiss a cookie alert box to like pull on the brake or anything like that. Like this is usually for kind of more visualization stuff, so it's not kind of like our onboard things aren't the same onboard things as a browser, but that's just thought I'd make that clear in case anyone is watching. So tonight what we're going to do is we're going to have a live demo as we mentioned before. And what I'm going to do is I'm going to give you a URL that you can load up on your other devices. And then as I'm going through the talk, you should be able to see this URL update with some content and stuff like that. And I want to kind of emphasize that I've never really kind of tried this particular approach before, and you'll kind of see why it's weird. And so I really, really hope it works, but you might have to bear with me. And if it doesn't work, I've got a backup plan, but it's just a bit more boring. So yeah, that's going to be that. So what I'm going to do is, if you get a second device and then type in this URL, so dev.benjaminbenben.com, and visit it on that device. And what you should see, I will load it here, is a black page that says offline. So yeah, hopefully you can see that. And I think it's just been put in the chat. So visit that, and I'll give you some time. I'm just going to disconnect this. Actually, no, I'll leave it there. Cool. So I'll give you a few minutes, and the URL's up in the bottom as well. So yeah, I think it should work on if you just a second device or a phone, it should be fine. You might have to refresh it a few times or something like that. Cool. Right. So that is that. Visit that, and we're going to go into some demos, right? Cool. Roy Richardson's got offline. That's good. That's we want to start offline and then move from there. Brilliant. Okay, cool. So what we're going to do is I'm going to start a web server, and we are going to go from there. Right. Okay. So there's something kind of interesting here, which is this looks like files on my local machine. It looks like so this is some HTML, but this is actually running in a instance in AWS in a data center in Ireland, actually. But so even as I edit these pages, as I edit these files, it's actually just changing in some data center somewhere. So what I'm going to do is I'm going to do npm start. I'm going to start a development server. And so now, hopefully, I'll just close this. If you refresh dev Benjamin Benben, you should see this is a web page. And hopefully you can see this. Cool. Josh and Will, can you see this as well? Cool, you can see that, Josh. Cool, wicked. Cool, right, okay, so this is where things get interesting. So this is now using a web server, which is connected. It's a development web server, and as I change things, so I can add some exclamation marks here. As I change it, it updates instantly. And I can add in more code here. It updates. Now, so the difficulty here is that because we're on a live stream, you're going to be seeing these updates apply before I actually say them, right? Like so, and I believe there's a difference in the delay between Facebook and YouTube as well. So it's like kind of a bit of a challenge, but kind of cool. Right? So how do we go around this? So what we're going to do is I'm going to introduce this delay. So this is just a tiny script that what this does is it will ask you where you're watching from, and hopefully, so I'm going to go direct because I'm right here. Hopefully what should happen is it should defer the updates to happen after an amount of time and should keep you kind of in sync. It might not totally work, but it should be better than nothing. And if you want to tweak it at all, this d equals 0 is the amount of seconds that it's delayed by, but we'll see. And yeah, and again, so this is the part that, as I was explaining before, I've never really tried this, so it might just watch out. Okay, cool. So now when I change this and add more exclamation marks, you should hopefully see it around the same time, right? Like, so it won't be perfect, but you should be able to kind of like see as I add and remove exclamation marks and that updates and stuff like that. Cool. I don't know if I have got some notes for this. I don't think I had anything else to say about it. Yeah, that'll do. Cool. So that's the first demo. We built a website, right? Like, so we can add as many exclamation marks as we want. So the first thing I wanted to talk about was loading in data. So, right, we've got this. I'm just going to take out this content here, and I'm going to load some JavaScript. So this is just a file here, which will load some content. So I can actually say alerts. Hello. Sorry, I can't type. And when I do that, you should see a kind of like annoying alert come up that tells you hello. And hopefully you saw that, but I don't know. I'm gonna hope. If anything goes wrong, refresh your page, and that's the nice thing about the web, right? Like, so, cool. Okay, so the first thing we're gonna do is, oh, I saved the wrong thing. The first thing I'm gonna do is we're gonna load in some data. Or show how data works. So basically, data on so data is just a series of ones and zeros, right? So this is going to generate a uint data array, a series of bytes that's 256 bytes long, and increments from 0 to 255. And what we're going to do is I'm going to bring in this viewer to visualize that, so we can kind of like discuss how this data works. So this is I'm just going to paste these in because I forgot how to write it, and I'm going to make this a bit bigger as well because we can have it bigger. Cool. So what we're going to do is we're going to create some data. We're going to create a viewer for that data, and then we're going to send the data to that viewer. So when I save this, you should see these ones and zeros. And so this is what is stored on a computer, and this is what like kind of comes through the network when we kind of request files and stuff like that. And you can see here we go from 0 to 1111110. So not totally up to 250. Oh, I'll change that. We go up to 256 here. So we can kind of you can see all those bytes. Really hard to understand because we're not a robot, right? Like Yeah, Simon, you're not a robot. You just said so. That's cool to know. So what we can do is we can make this a bit easier to understand by grouping these bytes. And we're going to use this notation called hexadecimal. So I'm going to just switch this over to hex. And we've kind of shrunk that down. And you might have seen kind of like when you see kind of serial codes written down, sometimes you see it in this format where it's kind of uses 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And that's got a really nice property for this because basically it aligns with the number of bytes per digit. Whereas if you use decimal, if you have the number 17, it might use 2 bytes. I don't know. It will use more bytes than 12, even though they've got the same number of digits. So that's cool. Still, this is quite a bit hard to kind of to grasp. So what we can do is we can colorize this. And what this does is it assigns a color from 0 to 256. So you can kind of like get a bit more of a feel for the data by just looking at it, right? Like, so you can see this is a kind of range of data growing from blue to red. And that's the kind of nice tool for us to use for that. So we know how to visualize binary data now, right? Like we can just put it on the screen. And so what we're going to do is we're going to pull one of those blobs of data, the packets of data from that Velodyne stream, and we're going to pull it through the same thing, right? So what I've got here, I was going to take this out manually, but I'm just going to paste it in. Instead of this UI rendering the data that we've got here, we're just going to do a fetch, which is basically like, give me that content. It's going to convert that into a buffer, which is a data construct. And then it's going to render it to the screen using our thing that we just created before, right? Like, so now you can see this is the actual data that has come from our lidar thing. And we can already see some kind of interesting stuff here, right? Like, so we can see all these Fs at the beginning. This part here, yeah, this is to do with the actual network level wrapping. It's a UDP packet, and so it has that data at the beginning. And then you can see these kind of repeated FE6, FE whatever. So these are, and if we move this around, you can kind of see how they align a bit more. These are the blocks in that diagram that I showed you before. So each of these relates to a block being reported back from the laser. And then these content here look a bit kind of, there's a bit of structure there, but I don't really know what it is. So we can kind of, yeah, that's probably going to be the data from the actual kind of like the distance and reflectance. So we can kind of like switch this. So that's the first packet. I'm going to switch this to the second packet, and we can see how it kind of changes, right? Like so, but some things have stayed the same. So basically, yeah, we can kind of switch between those two back and forth, which is kind of cool. But we can't really investigate it that much. And what we want to do here is we want to explore the data a bit more. So what we can do is to, I mentioned before about gathering things in a PCAP file. We can import something which can parse that file, so it can understand what that capture file contains, and then it can feed it out elsewhere. So what we're going to do is we're going to do a new PCAP, and this is we're gonna load in a 0.5 megabyte file, and then what we're going to do is we're going to stream this file to our UI, and this has another option, which is how fast we want it to go. So we're going to do it at 1,000th speed. So the packets are coming like super fast. We're going to slow that down quite a lot. And then what's going to happen is we're going to use that same UI to kind of show that data. So when I save this, you should see it's now, we're seeing the packets next to each other. And we just saw that kind of like a bigger flash there when I guess there was more data sensed at some point there. So I might speed that up a little bit. Yeah, so we're getting that a bit faster now. You can see at the top, there's a bar that shows you how far through this 0.5 megabyte file we are. And you can click on this to stop if you want to kind of explore a bit more and like look at it. So feel free to do that on your own machines. That's not synchronized. I wanted to do that, but I didn't have time. But that would have been a bit weird. But yeah, no, feel free to kind of have a play as you're going, and obviously refresh if you want. So something to note here is this is, I think, 500 bytes or something. And then, so this is less than half of the actual content of this packet. So we have got more information on that. So we have a stream, and we slowed down the data. That's cool. That was on my checklist. So there's something really interesting about how this is actually working underneath, and I'm going to say it really quickly in case anyone cares. Basically, what we're doing is we're not downloading the data and using that to pause reading it. We're actually pausing the actual incoming data. So it's kind of like it's reverse. It's changing around where that logic lives, and it makes it a lot more efficient. And if you're into JavaScript, you'll be like loving that. So it uses the web streams API. But okay, that's all I'm going to say about that. Cool. Right. So what do we have there? Right. So the next thing we want to do is we've kind of got an understanding of the data now. We know this is the packet header. We know these are the blobs. So basically what we can do is we can decode that, right? So what I'm going to do here is I'm going to change from bytes to an actual Velodyne debug. So what this does is it knows that structure. I don't want to delete that. It knows the structure that it's expecting, and it's able to kind of like convert that into something more meaningful. So when we say this, we can see this is now actually pulling out those distances of each beam. So we're able to kind of go from the raw data and without any kind of like back-end modification or anything like that, we're able to kind of like pull out the distance, the kind of like the time of flight, the reflectance of that coming back. And then the azimuth is as the thing is spinning around, the azimuth is increasing or decreasing? Increasing. So you can kind of see it kind of coming around. And then the elevation is fixed with the stride of the packet. So you can kind of, and that's the up and downness pretty much of what it sees. So yeah, we've got some cool data now, and that's good. Right, so we got some data, and we've talked about fetching stuff. I kind of talked about that. We talked about buffers and colors and stuff like that, and how to stream things for those of you who care about that. So yeah, that's part one. Cool, Dave. I just see that your JS book is getting dusted off tonight. That is, I'm glad to hear that. Give me a shout on Twitter if you want to, if you want to chat about that or anything like that. I'd be happy to. Yeah, I'm always into that. Cool. So the next part we're going to talk about is visualization. So we managed to like pull that content through, make sense of it, pull out some numbers. What should we do with that, right? So we're going to do lots of things. So the first thing we might want to do is, I will just consult if it is the first thing. Yeah, it is the first thing. So the first thing we want to do is we want to take this packet that we're seeing, and we want to pull out, like render it somehow, right? Like draw a picture with it. So what we can do is we can just change this to, not just change it. We can use a different viewer here, which uses HTML canvas, which is a different kind of way of drawing pixels to a screen. So you can say like, I want this pixel to be red, this pixel to be blue. I want a square over here. And we can take this viewer and pass that data straight into it. So we're doing exact same data. The only thing that's changed is what we're doing with it. So when I enable this, you can now see each of those pixels relates to a particular laser beam, right? And the height of it, I think, is the distance, and the color of it is the reflectance. So, and what you should hopefully be able to see from this, like, I mean, it's not very useful for data visualization, but you can see it looks quite lasery, right? Like, and it also looks like it's moving. You can kind of like, if you look at it, you can kind of see it kind of whizzing. And this also works if we increase the speed. So if we take it to like 50th time, it will speed up a little bit. And yes, it does look like a digital TV. It's like, yeah, no, it's, I guess that's kind of how TVs work. Cool. So we're going to slow that back down again, so it's more information. So what we're doing here is a one-to-one, a single packet to a single screen, right? Whereas our data actually, a packet represents a slice of that laser going around. So what we can do is we can make use of that, and we can plot lots of packets together. So one of the nice things about Canvas is that you can write. What's nice about Canvas? You can update it efficiently. So if you're adding the data into it, it works pretty well. So what we're going to do is we're going to create a wider canvas, and we're going to start plotting those packets along that canvas. And so what you can see now, you're starting to kind of get a bit more of the realness of the data. That was a terrible expression, but it's like you can see. I'll just pause this here. It looks like there's a thing here. I don't quite know what that is. I don't know what any of this is, but we can kind of like, there's definitely stuff there, right? Like, so you can kind of yeah, you can visualize that. And as it's sweeping across, this is changing slightly as well. That just came on. What else is happening as we're going across? It does look relatively stationary. So you can see that the sensor isn't moving around at that moment. It's like stationary in one spot. And there's, I think it looks like a reflectancy part up there. So there's something up high which is bouncing back quite a lot of data. And yeah, that's kind of cool. So then the last part of this, so we've got this canvas that we can kind of plot stuff to, but we've failed to make this map to real life, right? Like, so we're using the angle to kind of have the X coordinate across the page, and the azimuth is Y. Whereas actually, we could be making this seem a bit more. We could basically, what I'm trying to say is we can use maths. So we can work out, instead of like just trying to visualize it, we can work out what the 3D spaces are of each of these points and visualize that, right? So what we're going to do is we're going to change this to canvas circle, which you can probably guess what this is going to do. So this is using exact same data again, still pausable up the top, but it's plotting it on a radial surface. So you can kind of, we're using that azimuth to offset each of these pixels, and we're also able to plot the distance, use the distance in that point, so we can actually see stuff. So now we can see a whole bunch more things, right? These look like there might be some trees over here. That looks like a wall because it's quite flat. There's something over here which looks kind of sparkly. I guess that's the thing we saw before. And yeah, so we can kind of start making out some of the data. And as you saw before, we saw the amount of data that's held in one packet, and how complex it is to decode that. But we're doing that very rapidly in this situation as well. So yeah, cool. And I imagine this is still working for you, but we'll see. Hopefully. So yeah, we've got a canvas circle. Cool. Thanks, Will. That's cool. So yeah, we talked about visualization. We've talked about, did we talk about parsing in that? I don't know. We talked about kind of like pulling out data, drawing some squares, like drawing pictures, and then using maths to work out where things are in real life and visualize it more effectively, which is useful. I'm thirsty. Cool. Right. That wasn't a very well thought out slide. So the next part of this is I want to talk about graphics pipelines, right? Like, so I should really have had a slide for this. It would be easier to explain. But what happens, what we've done there is we are writing everything straight to a page, a graphics context, right? Like, so as data comes in, we're updating it. Whereas you can kind of structure this in a slightly different way, which is you pull in, as that data comes in, you update an object that that contains that data, and then and so you kind of organize it, and then in a completely different process, you can then tweak that. You can then visualize it independently. So basically, they can work almost like on different threads, and that's a kind of like a more, I wouldn't say modern, but a more kind of a better way of doing it. So we'll look into that. So what we're going to do is I'm going to just switch this back to canvas wide. Right. Okay. So that didn't work. Canvas wide. This is a development server, so you can see errors happen. So this is that canvas wide thing, which we saw before, where we're plotting the points. We're plotting those bits along the single canvas. Instead of that, we can use WebGL, which is a different. Oh, the wrong spelling. Which uses this kind of like this pipeline more effectively. So basically, what we'll do is we'll feed in the data, and then we will plot that data in a separate process. So when I save this, you can see this looks quite similar, possibly. Where is it? We might need to speed this up a little bit. Oh yeah, there it is. So it looks quite similar to that other view that we saw. We can see it sweeping by, but we've got a narrower field of view. But what's nice about this is that we can kind of like interact with it. So we can turn it around, and we can kind of like use that graphics power a bit more effectively. And we can even go up and down, and we can zoom out, so we can actually get a feel for the 3D space. So we can kind of like, by separating these two processes, we're able to visualize it in a richer way. So hopefully that makes sense. So we've got an interesting problem there, but we'll get into that. So something that we can see, like another aspect of this is it is super. Actually, what I'm going to do, I just saw a comment. We'll make it stick to the top by default. So sorry, this will flip it so that you'll be able to see it from the top. And on your phone, you should be able to like drag it round and explore it a bit more and pinch in to view it. I've got quite used to these controls, so if you have a problem, then just refresh the page and it should start again. And this pause data stream still works. So so one of the nice things about this is that it's very efficient, right? Like, so because we've got these two different processes doing different things, so instead of running at 100th speed, we can run it at 1/10 speed, and it's fine. But it also runs out of data quite quickly, so it runs through that. So what we're going to do is we're going to increase the size of that data. So let's, instead of 0.5 megabyte, let's load a megabyte, and let's speed it up to real time. Let's do that. So this is a megabyte of data, 10 megabytes of data at real time, and you should see that happening. You just see vehicles going past, and you can see the starts of some movement. You know, like, so you can see it start to pull out. So I think there's a road going up here, and the car starts to pull out right at the end of that clip. Actually, do you know what? I'm going to just plonk it up because it's more fun. Sorry, 25 megabytes. Yeah, we're seeing all sorts of things here. I'm going to refresh this and pause it, and we're going to have a look. So it looks like we've got a car here, some kind of roof there, and over here. Now I know this is here already. This looks like a person. So what we can do is we can actually zoom in here, and when we repause the stream, you should be able to see that person walking across. So we can kind of like, we can start kind of explore the data a bit more, stuff that we couldn't see in any of those other views at all. Which gets a bit confusing. Cool. So what have we talked about there? We have talked about those at-works. Wicked. Sorry, I'm trying to synchronize different screens here. Yeah, that's great. That works. Right. Okay. Cool. So another aspect of this, which this is, I'm very excited about this. But I was excited about the streams, but I'm even more excited about this. Is that we can actually do this. We can change the way this is rendered. So this graphics pipeline, you construct it with JavaScript, but it also has ability to use different languages within it. So what I'm going to do is I'm going to play around with this a little bit, and we're going to see what kind of things we can do. And again, this should update in a slightly different way on your device. So rather than reloading the page, it should update dynamically, just swapping out those shaders, which will swap how things are rendered and how they look. So the first thing we're going to look at, the only thing we're going to look at, is this vertex shader. So where are we here? So I have not prepared this very well. But the first thing we're going to do is, so just now the colors are just static, pink, as you can see. So let's color them instead by the distance from the camera. So this is saying color value is the length of the distance up, and it divides it by 30 because we're mapping it to 0, 1, and a bit more. And so when we apply that, you can see this kind of snazzy rainbow. And what's nice is that you saw that the data didn't actually switch, right? Like, so we didn't switch views, we just swapped out the way of visualizing that. And if we were to change this to maybe being a bit, so we've cut out some information here. So we might want to increase that to 60 meters, and then it kind of, we can see stuff that's further away, and we can kind of start interrogating stuff a bit more by looking at this. Yeah, there are rainbows. Yeah. So the next thing, rainbow by distance. So this is, again, you can play around with these. So if we wanted to make this color by X value, we can switch that, and you can see that now it's using the X value of that point and coloring it accordingly. We can even do stuff like using the X and Y value, which is a bit harder to see, but this varies it by both X and Y values, but not Z. And so you can kind of like do all these kind of things and play around with it. We can make a rainbow by using a sine wave. And so this takes the position of the X, or actually it takes a position and rainbowifies it. So makes it kind of nice and neon-y, which is kind of cool. So we can do this kind of stuff. And same as before, if we change this to just the X coordinate, we get other things like this. I'm going to try, actually, just make it smaller. Cool. Okay. We can bring in other parameters in here as well. So now if we bring in time as a parameter, which is like time goes forward, so we can now animate those values, right? So this is doing the same thing, but also introducing this time variable and some kind of magic numbers that I've shoved in here. And now we get kind of like a slow pulsing out, you know, like just to go full on Tron, as Alban says. Like that's yeah, that's what we want out of this. I'm a big fan of the pulsing rainbows, but they're not incredibly useful. Like I'm sad to report. So we can color these by intensity instead. So this shows, as I said before, things that are reflective more. You can see across here, you can see the side of that car is quite reflective. So I guess it's a metal van, I guess. And you can see over here, I don't know, I'm not sure what it is, but it definitely reflects. And I think if we follow this on and play it a little bit, we should be able to see stuff like this. So if we go down here, you can see that this is a traffic sign over here. because traffic signs are super reflective. So you can see those green patches here are that traffic sign, and that over there as well, which is kind of useful. Cool. Right. So now that we've got that, I'm just going to let this play through and start again. Right. So we've got this thing here. We can look at the data. There is something odd about this. Now, I would ask, so what's odd about this? I mean, obviously it's all odd because it's like a kind of weird rainbow thing. But looking at this, what happens is, what's odd about this is that the points that are further away are the same size as the points that are close to you. And this is something in graphics, which is like quite a challenge, because you have to kind of like articulate things that you just know intuitively. So what we can do is, if we switch this, so if you orient your screen to something like this, so you can kind of see this problem, and then what we can do is we can accentuate the distance, and now we've got like the closer pixels are bigger and the further ones are smaller, which is a bit more natural, right? Like, so we can kind of see even just like dragging around like this, you get a lot more of a kind of feel for it, right? Like, so. Yeah, that's kind of cool. So as well as that, so there's this other like physical aspect of the lasers, which is that the laser isn't a straight line. It's actually a cone. It's a bit more than a cone. I was learning this the other day, and it's incredibly complex and brilliant. But it's kind of, it disperses out as it goes further. And so if you think of a dot down here, it'll be a tiny little dot. Whereas if you think of a dot across here, it'll actually be quite big. And we can kind of like model that dispersion in a hacky way by doing this. And so you can see now that the bigger ones are further away and the smaller ones are closer in. And this is quite handy for looking at more detail. Oh, where have I gone? So we can make out more details of this car here when we do it like that, because you can see that the actual, before it was quite hard to kind of actually see those details because it was not so close together. Yeah, so we can do that. We can still play it. That all kind of works. A kind of fun one that I like, which is like kind of a combination of what we just talked about with the intensity. So what we can do is we can bring time into this. And so this, what this function here does is it changes the size of the point based on the intensity and using time. So what this will do is it will make the ones that are more reflective sparkle, like pulse a bit more. Not a bit more, just pulse. So if you enable that, you can see we get this like super trippy effect, which we should be able to see. Oh, I'm not scrolling too well here. So you can see that these ones here are pulsing at a bit of a higher rate than the other ones because they've got higher intensity. And I really like this because it is like the worst data visualization thing you could probably ever do, but it's kind of looks cool. So yeah, those are some things you can do with that. If you're interested in this kind of stuff, like this is a vertex shader that happens in a particular part of the pipeline. We've also got another thing, which is a fragment shader. And using this, you can kind of like do stuff like we can make it squares instead. We can do, I don't know what this does, maybe make things transparent. So you can kind of play around with it. And you can kind of like explore the data a bit more. And yeah, you can even kind of hide stuff. I hadn't thought of this until just now, but you can hide stuff based on the color value. So basically, if I say if the color value is more than 0.5, discard that. So that should be, I don't know if that worked. Maybe it's 50. That didn't work. I think there's probably something wrong with that. Ah, well, you could do other things if I had patience to do it. Rainbow, I'll change that to that. That's kind of cool, isn't it? No, the other one's better. Cool. Sorry, I'm not going to dig into this too much. Okay, cool. So we've done all that stuff. We've got some kind of pretty looking things here, and we can still play with it. Was that everything that I wanted to talk about at that point? I think so. Cool. So we've had a look at WebGL. is the main thing, right? Like so. That is this graphics pipeline, and we looked at shaders, which we can play around with and make. Do you know what? I'm going to turn this back to being a rainbow by position and time because it's cooler. So we can kind of play around with those shaders and do cool things. I hope this is making sense and stuff. And even if it's not, I hope it's looking kind of pretty for you. Cool. So the last part of this was other devices. So the nice thing about the web, right, is that browsers are so different, right? Like, so you might think of other browsers as being Safari. Oh, we're going to go direct. Like Safari, Firefox, all like Chrome, all brilliant things, and they're all quite similar. But we've got other devices that render things completely differently. Like, hopefully, some of you are watching this on your phone, and you can kind of play around with it like that. And what's cool is that the web as a platform allows us to kind of deploy our stuff onto completely different things. So what I'm going to do is I'm going to load this on my telephone, and how I'm going to show you this is I'm going to share my screen. This is where things get a bit sketchy. Screencast to my laptop. Start now. And what I'm going to do, just so you can see it better, is I'm going to rotate it around that way. Cool. So you can see we've got this phone here, and I'm able to, hopefully like you are back at home, I'm able to stop stuff, turn it around, do all that kind of thing. I'm able to kind of see that rainbow and see those pulses. We can, sorry, that is a really good shout, Will. Sorry, I didn't realize that could be bigger. I'm going to close that, and there. That's better, right? Cool. That was a good one. Yeah, so as you can see, I can kind of play around. This is, I can use multiple fingers to zoom in and out. So it's really kind of cool that I can use the same content on an entirely different browser type. Something that's cool about this particular browser is that it's got some kind of cool features for augmented reality. And what we can do is we can enable this in the way that I do it. So this is so terrible, but I'm going to enable augmented reality features on this. And now I get this button, which is start AR and start VR. So AR is augmented reality, and VR is virtual reality. So I'm going to do the AR one. And what you can see is, oh, that is weird. That's kind of embarrassing. Let's try that again. I think it was because I rotated it to the side. So what we can do is I hit that start AR button again. Okay, cool. One sec. Hopefully no one phones me at this time. I'm going to disconnect, and I'm going to reconnect at this. Thing here. Cool. So we can see that. Start AR. I'm going to press that. And nope, I'm going to do it this way. Yeah, I love live demos. This is cool. Right, okay, so we're going to start AR this way and not see that at all either. Cool. Well, at least I've got this on video, so I can Chrome. Direct, start AR. Here we go. Right, okay. So what we've got is, I mean, this is quite intense, but you can see you got my laptop, and you can see we've got this kind of, all this data, and we can still change around stuff. Like, so I'm going to change this vertex is down in AR. We want it down to like 3, 2. You can change that to be a bit more reasonable. And now we can kind of explore it in a different way. So we can kind of like go right up to objects and see. I mean, it's not a very particularly useful way, but it's kind of cool. So we can see that kind of stuff. So that's one kind of device that has a browser, which is powerful. But as I said, other devices have browsers too. Another one is this. So this is a virtual reality headset. This is called Oculus Quest. This is the Oculus Quest 1. There's an Oculus Quest 2 now, which is like twice as cool, I guess, going by the numbers. And yeah, this also has a browser in. And I'm going to show you this because it's quite an interesting thing of like what a browser is like in VR. So this is going to be, I'm sorry if this is going to be awkward for like a minute while I set this up. But, and also I'm going to take off these headphones. Right. I need to find these. Cool. Right, sharing, and I'm gonna cast this, and I'm gonna cast it to, oh dear. This is very cool when it works, but it takes a little bit of setting up. Quit air server. Air server. Now again. There we go. All right, okay, so we're gonna connect to that. Next. Casting request sent. Cast. Ben Foxall. See, casting request sent. Okay, this is kind of rebroadcast services. If this doesn't work, you're just going to have to believe me at how cool it is. Okay, it doesn't work. I can maybe try and get that working after a bit of a break if we have time, but.
Yeah, don't worry, dude. Don't worry.
Cool.
Live stuff is. I mean, the things you've shown already is superb.
Cool. I can actually show you a video, so that kind of works. But cool. But thanks. Yeah, no, my computer is kind of crashing at the moment, so that's not so good. But one sec. Disconnect. Right, let's try this. Okay, cool. I will show you a video of actually, I won't show a video. I'll post it in some chat or something like that. But basically, you can walk around and you can really walk into stuff and really feel it, and it's pretty cool. Cool. Right. Okay. So I will post it there, and you can play it. In fact, actually, Josh, thinking about it, I tweeted it a couple of days ago. I tweeted a video. So if you wanted to kind of put it on there, that'd be cool. So yeah, what I talked about there is like WebXR. So XR encompasses AR, augmented reality, and virtual reality, and gives us kind of common API for both of them to work together. And yeah, I'm like, I think this is dead exciting. And there's something like, I think this feels like there's sometimes an apprehension about people using browsers to do like weird things, you know, like as in it should just be a browser, it could show content. But I think from the very beginning, browsers have always been on the kind of cutting edge of the hardware and making use of it. So I think it's very kind of like in line with that. Cool. Right. So we've talked about those things. Right. Okay. So this is part that I'm not really prepared that well, but I thought it would be interesting to show. So just to kind of bring this back to the kind of stuff that we do at Oxbotica. So that is this data that we showed. So this Velodyne puck VLP16. This is a really cool sensor, but it's also I would just want to show you quickly some of the kind of data that we're dealing with at Oxbotica in other kind of web tools with stuff. So I've got a massive video here. So I guess, can you see this? So yeah, hopefully. Cool. Well, good. So what we've got here is this is actually a screen grab from a web page, and it's showing 10 centimeters of data. So this is like the car is driven 10 centimeters with a thing on top spinning around, and this is the kind of the content that we've managed to kind of pull from it, and it's dealing with this all the time. So you can see as we go in, there's a bit more data, it's more dense. And as we kind of play around with this, you can kind of see when we pan, there's a lot more to it. And as we zoom out, the difference with this sensor, this is not working so well. As we zoom out, you can see the content covers a lot more range. So we can kind of like, you can see out here is like 100 meters or something like that, maybe a bit more. And then, yeah, and you can make out these buildings. And so this is, if you compare this to what we were seeing on that screen, we've got a lot richer data. Granted, it isn't a throbbing rainbow or anything like that, but it's still kind of cool. So then what we can do in this, so this is, as I said, a web app. And the next thing we're going to do is we're going to load in data collected over a longer period of time. So using this tool, you can select, so that was a single point. We've got data for this whole loop, but I'm going to select like 10, 50 meters. And then we're going to load up the point clouds for that, all in this web-based tool. And then that gives us something like this, which is like a lot more data. Like, so you're going to make out a lot more details and a lot more kind of the content of it and stuff like that. This is actually our office, so you can kind of like, I know it very well. And we can kind of play around with some of the visualization options in that same technique that I showed before, where you're kind of like modifying properties of those shaders. And we can kind of see, oh yeah, this is what's cool. So this is a person, right? Like, so because we've gone over time, like because we've captured point clouds over distance, but also time, this, when someone's walking along, you basically see them as a smear of dots, right? Like, so this is I think it's two people walking along and one, yeah, so you can kind of see that kind of stuff, which is fascinating. These are colored by the height, which is often a useful way of doing it. I really love this kind of stuff. So you can see these people coming down here, and they've been captured as a smear. You can see a van over here. But you can also see these stairs, and inside there's another set of stairs. And these are actually a reflection of the laser, right? So there's a glass window here, and the laser has come from this point here, gone in there, bounced and hit those staircase, which has then projected that staircase into this space here. And like, I find this like mind-boggling that you can kind of like have reflections in 3D of laser points, and you can see there's a reflection of the people here as well. So you can kind of see that kind of data that we've got. I forget what happens next in this demo. This is, as we've driven past our office, you can actually make out some of these. These aren't reflections, these are internal walls. So the car drove from here up to here. And during that time, you're able to kind of make out, so the front of our building is fully glass, and so you can make out the front desk and all that kind of stuff. And yeah, all this kind of detail is available and kind of browsable. I think that's what I'm showing here. I forget. I miss the office. It's kind of nice to be able to visit it virtually through these kind of tools. And yeah, I think so. The next thing I was going to show is particularly special. So something that's nice is you're able to. We've got multiple sensors in the car, as I showed you before, and so those sensors we can combine. So we know points, and we've also got cameras, and we know which direction the cameras are pointing. So we can use that to project colors into a point cloud. So what we're going to do here is, I think at this point, is switch to a colorized point cloud version. So this is actually kind of said, like it's combined those kind of multiple sensors and brought them together. So yeah, we kind of go over, what do we switch to there? Go up to that van, and you can see something really interesting here, which is like, so the colors are, the points in front are colored and the points behind aren't. And that's because we had cameras physically pointing forward. And so you can kind of, so that's why we don't have color data for the ones behind us on this particular setup of this vehicle on that day. And then, yeah, you kind of, yeah, you get to play with all this stuff. And it's really fun. And it's all kind of like just maths, really. And yep, there is, what do we do next? And then I think the last thing that I showed here is the colorizing by reflection. So using this, you can actually see those points that have high reflectivity indexes or something. But yeah, that's that. And we can kind of play around with that, and it's like we're at the office. Cool. And yeah, I think that's pretty much what I've got to say. So I had some slides about other bits, but I didn't expect this to take so long, but I end up talking quite a lot. So thanks a lot for listening. And yeah, like I hope that it's been interesting for you and that you've had a play around and stuff like that. So cheers.
Perfect. Thank you, Ben. I think normally at this point you would have a round of applause, but online, so
cool.
there's going to be me applauding on behalf.
That's all I need. That's like that.
So thank you for that. It's I think really interesting for everyone, and it just shows. I mean, just watching you code along, live, it is pretty awesome for myself, but I'm sure the majority of our members as well.
Cool. I'm glad. Yeah. Thanks.
And feel free to anyone's got any questions to chuck that in the comments quick now. The one question that seems to keep coming up was what's the minimum resolution of those cameras to make it sort of useful and usable, and also the distance. How far are we looking from that camera?
For the colorizing of the point clouds. Yeah. So it'll kind of, I guess. So again, this is one of those things I don't totally know, but I can guess, and it's like you could basically do it with anything, but the quality of the colorization will change. So for some, like, so it's really interesting. Like say if a camera, for instance, is blurry, then you're going to see that blur on the 3D points as well, right? Like, so you're going to be able to, or if it's miscalibrated, maybe you might see a kind of a shadow of an object, and it's like as I mentioned with the as I mentioned with the reflections, it's like I love being able to, like, when you're actually like looking into it, and kind of debugging physical spaces. It's really kind of like mind-boggling. But yeah.
Awesome. And you've had numerous rounds of applause via emojis, which I think is probably the best we can take in 2021.
I'll definitely take that.
Lots of thank yous. Really awesome. And I think for me, it's that being able to watch it live, like on your phone as well. Like, it just makes it extra special. So you've had lots of some really nice comments. And did you reference that distance? So what was the comment exactly? I'll just try to pull it up. Let me just find it. What is the distance range from the vehicle? Did you just? Sorry, I was unsure.
Yeah, no, I did. So again, like, we're kind of like sensor agnostic, like, so we might one day have a radar that can see for miles, or a lidar that can see for like short distances, but our kind of universal autonomy is about being able to adapt to those, and there's like such interesting things that some sensors might perform better than others. Like, say if you're in a desert, then maybe a lidar doesn't give you that much information. But then GPS might. But then if you're underground, then you might not have a GPS signal, or if you're in a city, GPS is rubbish. So it's like being able to like switch between different systems is a challenge, and kind of interesting.
Awesome. Yeah, makes sense. So I think you've answered everybody's questions. I mean, just sitting and watching is pretty awesome. What is the constraints with something like rain or snow? How does that work? How does that come into play? Yeah. I mean, they are constraints. I guess. I know it's not your sort of day job looking at that, so it's a difficult question to ask you in some ways.
No, I mean, it's a really good question. I think I don't think I'd be able to do it justice, to be honest. Like, I know we do have. I work with people who would be able to dance this amazingly, and it's like, but yeah, I mean, being able to like test sensors in different conditions, like, so we test a lot, so we've got a relatively big set of cars, and like we managed to get a big range of different conditions, which is useful to have that data and stuff.
And I guess it's all about those different sensors. It's the trying to use all of them at the same time to try and picture everything. Things do change.
Totally.
Lots of people. Again, another person, Ron, here is coming up saying, "Loved your enthusiasm."
Cool.
Yeah. So, and I think there's quite a few people that know code, but are like, actually, I need to go back to the books, and that's damn interesting. So that's really cool to see. So there was a couple of people about lidar again, sort of, and it's a difficult one for Ben to answer really, because we know it's a big topic for Elon's categorically said that for Tesla there will not be lidar. However, the sister company SpaceX uses them every single day. So it's not like the technology is poor. It's just that in Tesla's opinion at the moment, or certainly Elon's opinion, it's not something they think for the Tesla vehicles. But as I say, SpaceX is pretty big. It's not like it's just a little mini startup doing like random stuff on the side. So they're obviously using lidar. I mean, docking onto the ISS uses lidar. So it's quite a big thing. So clearly it has its perks.
One of the cool things related to what I was talking about is like SpaceX in their interfaces for the astronauts, they use WebGL in that interface. And so it's just like, that's like, for web people, it's like, yes. It's like,
that's cool. So any other questions I think coming through, but I think just sort of a thank you from us really. It's really interesting to watch. Now, if people are watching this afterwards, will that URL work for a bit, or is that
unfortunately not? It's like it's yeah, for a variety of reasons. It's like
I'll double check and we can find out. But yeah, that is, it's so cool just to watch. I mean, I was saying like rainbows, it looks exciting, but just sitting there and actually for me playing with it on a Mac larger screen compared to my phone is quite cool as well. You compare the difference. So
I'm glad it worked. I'd be really eager to find out how the delayed stuff worked on Facebook and stuff like that. Like if it was like in sync or not. But that was I didn't expect you to do that. That was quite a added thing because we know there was a delay until like a few days ago.
So again, sort of just a big thank you really from our members for chatting and showing what you do. And I mean, I guess it's not really your day job, but it's just sort of like having a play with data that is available and seeing what's available, what works, which is awesome. So yeah, thank you. Was there anything else you wanted to sort of show or plug or say? You know, come and follow me on Twitter. We've got that. The other thing, obviously, at the moment, for anyone that is watching, we do have a chosen charity for 2020 and 2021, which is Mind, the mental health charity. So we are all affected by mental health, regardless of how much is in your bank account or how much, what car you drive or anything like that. So take a look at Mind. I think it's .org.uk, but also to donate, we've got a justgiving.com/Tesla Owners UK. So if you enjoy these sort of things, instead of, you might have bought a beer at the bar for £5, chuck that in, maybe £5, 10 quid, just as a sort of thank you. It makes it all worthwhile to us. And obviously subscribe to us on YouTube, follow us on Twitter, and also follow Ben on Twitter as well. So a big thank you again for giving up your evening and showing something awesome. Any questions? I'm sure I'm sure you're up for speaking on Twitter, but
there was something I wanted to plug actually.
Go for it.
I just thought about it just now. So me and a few people have been running this thing called Remote Hack. So if anyone is wanting to dust off their JavaScript stuff, basically we get together every month and just build little things, and it's really chill, and you can do basically whatever you want. But if anyone's interested, I might drop the link to you. But it's basically Remote Hack, and it's this Saturday. And it's just a kind of get together. And if people want to like learn JavaScript, it'd be a perfect thing to do there. So
perfect. Yeah, sounds good. We've got lots of techie people. So
cool.
Yeah, feel free. Cool. Perfect. Well, thank you so much, Ben. Thank you for giving up your Thursday evening. It's much appreciated. And we will see you soon, everybody. Thank you so much. I will turn us all off. Have a good one. Cheers.
Bye.